To understand the sample distribution of a sample mean, let us use the following case. We have data of number of cases by 6 partners from a law firm, Taibo and Associates. Presented in the first column of the table are the name of the partners, and the second column are the number of cases each partners have tried in court last month. To construct the sample distribution of sample mean from our case here, let us use the following question. The first step is we will make samples from population data of 6 number of cases from 6 partners. Then we will compute the mean from each sample. The third step is we will calculate the overall mean from the sample mean we obtain in the second step. And the fourth, we will compare the distribution of the population and the sample. So let us now start answering each of the 4 questions here. Our first step is to make a sample by taking a sample of 3 from a total of 6 population. Because there are 6 associates which we regard as our population, how many samples can we create? Based on the counting rules, we will have 20 samples. And this table shows the 20 samples that can be drawn from our population. Next, I would like to show you here why sample mean can be used as an estimate of the population mean. We first find the population mean. So here I show you again our population, the associates from the law firm, and the number of each of their cases tried in the court. Thus, the average number of cases tried in the court is 2.67 cases. So this is our population mean. And let's look at our sample. Remember, we can draw 20 sample of 3 from 6 population. And this is the mean from each sample, and we call it as sample mean. Or later, when we create a probability distribution, this sample mean is our random variable. And if we take the average of the 20 sample, we will get 2.67, which is just equal to the population mean. From the sample drawing process I have showed you, we can now see why a sample mean can be used as an estimator of a population mean. This value of the average of the sample mean is an estimate for the population. And we can say that the sample mean is the estimator for the population mean. In other words, the value is the estimate and the sample mean itself is an estimator. Now, let us construct the distribution. I would like to show you first the sample distribution of the sample mean. Based on all the possible samples taken from this population, we have 20 samples. This is the sample mean and the frequency of each of the sample mean that occur from the 20 samples that we have drawn from the population. And based on the frequency table of the sample mean, we can construct the sample distribution of the sample mean. Now, as a comparison, let us also construct the population distribution. This is the frequency table of the number of cases of each associates. From the frequency table, we can construct the population distribution. Now that you have understand how a sample distribution of a sample mean is distributed, we may conclude that the mean of the sample mean is exactly equal to the population mean. The dispersion of the sampling distribution of sample mean is narrower than the population distribution. You can see here that the population mean has a range between 0 and 6, which has a wider dispersion compared with the sample distribution with a range between 1.33 to 4. Thus, the sampling distribution of sample mean tend to become bell-shaped and to approximate the normal probability distribution, while our population distribution is skewed to the left. Now that you have understand about the sample distribution of sample mean, I would like to add some additional notes here. Based on the example I have shown you on constructing the sample distribution of the sample mean, the mean of the sampling distribution is the population mean, or the expected value of the sample mean is just equal to the population mean. Thus, the sample mean is an unbiased estimator of the population mean because sample mean is just equal to population mean. The standard deviation of the sampling distribution of the sample mean, or also known as the standard error of the mean, is equal to the population standard deviation divided by the square root of the number of observation. Based on this formula, we can see that as the number of observation, or the n, gets larger, the standard error of the mean will get smaller, which you will see later from the central limit theorem, the reason why a larger sample is preferred.